Yeah.
Hello, everyone, and welcome to this Talent Track, an event where we invite new talent winners to present their work. I'm Julia Doñate, and I'm the project manager of the UX Design Awards.
Hi there, and I'm Ák Rudolf. I'm the director of UX Design Awards and head of strategy at International Design Center Berlin. We're the organizers of the UX Design Awards.
Today, we will talk about two projects. We will start with 3D measuring system by Adrian Wiepcke, Daniel Gladha, and Steven Tennant, which was developed in 𝐌𝐞𝐚𝐬𝐿 University of Applied Science. After this presentation, we will host the Q&A, so please add your questions in the chat and we will pass it to the speakers. After we will listen to this first project, we will listen to the second one, which is Structra Modular VSM by Zaki Razak. A few words about the 3D measuring system. It's an easy-to-use 3D measuring tool that connects real-world measurements directly to digital planning software for architects and builders. Before we start listening to Adrian, we wanted to mention a few insights from the jury, which was impressed by this project because its ergonomic and modern design makes it comfortable to use alone with a 360 optical tracking and real-time guidance. It solves a real problem by eliminating error measurements that cause rework and extra site visits, and it uses seamless digital integration to instantly export CAD-ready data with real-time validation and surface measurements. That said, Adrian, the screen is yours.
Hey, hello, and thank you very much for being part of this great event. I feel quite honored to be awarded with the UX Design Award New Talent 2026. And with that, I would like to show what we have done in order to get that audience. So, the project 3D measurement system was a tool for craftsmanship that has been created in collaboration with the company Festool. It was a master project of the University of Applied Sciences Magdeburg-Stendal, together with my colleagues Daniel Gladha and Steven Tennant, and the supervisors Professor Jan Beese and Tim Büttner from Festool. I would like to introduce this project with the question of why is a product like this needed and why we started to work on it. We have the situation that we have to, workers have to measure interior spaces in order to make constructions and plans for interior designs, especially when it comes to furniture or even construction sites. Right now, they're using 2D tools to measure distances and then draw it by hand on a plan or in a digital way in a CAD system. So there are multiple points of failure, for example, transferring the data from your device to your CAD system, or even tracking everything that you would need in order to create a real 3D model. This is also a problem because there is a barrier to 3D softwares that often, have open standards but not dedicated solutions for capturing. So current workflows offer a lot of points of failure. The time increases in the process, and the manual transfer, of course, creates friction and even errors. So the missing context between the real working site and the planning is often a big problem for workers. So who are the workers actually? So we figured out some occupations that really need to get precise data from construction site, for example, engineers, interior designers, or even kitchen planners, which is a good example to explain why this project needs some more work put into it. And what's most important for them is basically the accuracy. That's a big thing that most of solutions lack of. They have to give you the capability to take fast captures as one person operation, and you need real-time feedback on site. Also seeing the result of measurements that you have on site. And of course, all this data has to be transferred to your CAD system of choice, which is also in construction sites pretty familiar these days. It has to be an easy setup, it has to be portable, and in the end, you want to create a digital twin of the construction site you are just in right now. The current solutions are quite sketchy right now. So there are common measurement tools for private users that just measure a certain distance. They are quite cheap and the accuracy is more or less okay, but not enough in order to make good furniture planning that fits in your apartment, for example. And on the other hand, you have professional 3D systems that are quite accurate, but sometimes they are so complicated that you would need separate service to make those measurements. And on the other hand, yeah, they are quite costly. They are, yeah, quite hard to use, not for everyone who is working on a construction site. So there are a lot of compromises, and we want to combine all of them in order to focus on what, for example, a kitchen builder actually uses and needs. So we figured out some key benefits that we would have to deliver with this product. Of course, it's a 3D point tracking with the maximum of accuracy that we can get. We're talking about an aim of a sub-millimeter level accuracy. So we have to deliver technology for that. We have to deliver 360-degree tracking because sometimes it's not just one area of a room, but the whole room. We have to make sure that there's a real-time mapping ongoing on the device. So the interface is quite important. Wireless workflow, of course, a direct export to CAD and so on, real-time edit on the device on site, and low complexity. Also, we had the opportunity to give you a system fit since we are in the Festool universe, which already has a lot of devices. So we also had to be aware of that. The design requirements that just came up after those priorities are that we have basically, and I will explain this later, a two-device system. We have a handheld and we have a base station. And the things that made the design so unique on this project was that we have an ergonomic handheld, which is quite important since this is what you have to use in order to make the most precise measurements. You have to deliver visible reference points. So that means that whatever situation you have, the base station and the handheld has to be connected all the time. An integrated interface, so you have to edit and use the device exactly in the point where you are, which is the handheld, for example. And we offer a lot more opportunities with a system that lets you interchange, for example, the measurement tips. So there's a lot beyond that you could do with a system like that. But for now, it's just measurement. And on the side of the base station, of course, 360-degree coverage. We need an integrated computation because you don't want to rely on any cloud services on places that are quite off. And you need a compact architecture that you just can store and bring everywhere. How does it actually work? So there are basically 4 steps that we are going to get in a little bit more afterwards, but for now it is basically 4 main points. First of all, you have to set it up and let it initialize. Then you can make your capturings with the handheld, and you can also be aware of different areas in a room. So we are talking about a range of sub-millimeter level accuracy of 10 meters and at least 20 meters with still an efficient accuracy that lets you work on most projects. Then you can directly edit the capturings on the device. And finally, and that's the last step, export it in real time to any CAD system you have. So even with a synchronization that lets others offsite edit and comment your actual capturings. As I said, first of all, you initialize and you calibrate. This is also done by an auto connection and a guided setup, so you won't take any mistakes compared to more complicated laser scanning systems. You've got a live progress, so you always see what's going on, what's going good and not. And a quick reference is a system that lets you come back to a site, let's say days or weeks after you took your first measurements, and make any changes afterwards, which is actually quite common if maybe you forgot about any area to measure. Then, of course, you pick up your capturing points. You get instant feedback about their position, and if everything is successful, you can also choose in between different tools like planes or 3D areas. And yeah, in this way, you just go forward from point to point. This continuous capture also offers like curved lines in a room. You can create planes, so you can manually say this is a wall or there's something in the wall that I have to mention later on. Also, of course, curved surfaces, and there's basically no limit in complexity of the CAD file that you're actually creating. You can manage those capturings. You can yeah, have a live preview on it, or even afterwards, you can edit those elements. You can get informations about single areas like length, position, and so on. And you can, in this way, like inspect every detail just on site, which is quite important. And of course, as I said, there's a live synchronization if you want to an offsite planner, for example, who can tell you, I need some more measurements, please take them, do that right now, something like that. So if there's a problem, for example, a connection lost, I will go into the technical situation a little bit later, but then the whole device will tell you by its display and also by a light ring. This happens immediately. Of course, you have a fast recovery. This is just quite important because then you have to stop taking measurements. So in order to avoid any errors, you have to get instant feedback in order to correct your position. So the whole process is basically the handheld transmits the data that you took and that you edit on the screen on the HMI to the base station. And at the same time, the base station tracks the position of the handheld with a technology that is a combination of optical tracking and infrared and time-of-flight lasers. And this combination makes the system so accurate. This is also the reason why you need a handheld, since pure laser systems often have, depending on the distance and the technology, of course, quite a big tolerance, and you avoid that by having a separate physical device just on the point where you are right now. And this point is being transmitted by Wi-Fi, and of course, the position is tracked by the base station. The handheld itself has a lot of features that offer more than what the aim was right now. So we are talking about an ecosystem. Of course, we have interchangeable tip that could be changed with any tip or every application you would like to measure something. You have reference wings with those markers that show the position to the base station. Those are placed on the outside and also on the inside. So even you are doing overhead operations, everything is visible still. And then you get an extension support for areas where you can't reach by hand. You just plug it in, and then you have a button to record everything. And this is also the reason why we have the light ring on the handheld, since when your handheld is up there somewhere with the stick, then you can see the light ring instead of the display. And of course, the ergonomics is quite an important part on that. So you have to reach everything every time. So we have big areas where even bigger hands can fit in. For the base station, of course, we have those cameras combined with infrared LEDs. We have the compatibility with a tripod. For some reasons, we have to lift it up, especially when you have pretty high rooms. So we offer this as an option that everybody can use with an open system. We have dual transfer paths for data transmitting and charging on the device, and interchangeable footings. That means if you want to work on a rough space, maybe you use those metal footings. If you want to use this product in an, let's say, high quality wooden floor, then you would change them with rubber feet, for example. For the techniques, like the body is designed within a package that contains everything you need, from a battery that really lasts for charging the base station and the handheld for quite a long time, depending on the usage, of course. This is the two-way power source, of course. We are using open source hardware, since we can plan with decent power consumptions and also capabilities on software side. That's an embedded architecture with on-board processing that offers everything being done on site and just uploaded live or afterwards. On the camera side, we have 130-degree lenses that really capture everything you would like to capture in a room within the range I told. And so we get the sub-millimeter potential and accuracy. Of course, we also have a system fit. We are talking about Festool, so they have their sustainer fit. The reason is every device of Festool contains a sustainer, so you can just stack them, you can put them in your car, and you can make sure that everything is in the same format. But the most important thing is that you can organize anything, also in this case, just everything fits in there. You can protect it, it has a compact footprint, and everything is ready. So there's no messing up and no damage happening, actually. For the design process, of course, we iterated a lot, and the challenge was to find something that fits within the Festool design language, and they have quite a sometimes bold but soft design language with big shapes and rounded curves. So this is an ergonomic choice, and we just took that ergonomic choice and implicated on our product. So this is the way we deliver the brand fit to Festools. And in the same way, we have a formal, reduced complexity when it comes to the shape, because every complicated detail is hidden in broad and soft surfaces. So only the things that really matter stay off in a impactful way. And therefore, we developed this quirky shape, which continues throughout the base station and also the handheld, of course, as a signature element and every other detail as well. And the project actually was, as I said, quite a successful project for us as students, but especially for Festool. It has also the potential to give a strategic direction in the field of measurement, which was the topic that we have been working on. And the project outcome is basically not only a technical foundation that can be adopted and developed even further, but it's also a way to say that we are aware of what our customers want. Because for all time for the project, we have always been thinking and talking about the actual customers of Festool and what their workflow looks like and how we could help them with such a concept. In this way, I would like to thank you very much for your time. Thank you for joining. Thank you for receiving the UX Design Award. And this also goes to Daniel Glatter and Steven Tian for this incredible work, as well as every other person involved in the project. Thank you very much.
Thank you very much, Adrian. It was very interesting. Thank you very much for those insights, and congratulations again for the awards. I have a few questions, so if you don't mind, I'll ask them. My first one would be, what was the biggest challenge you faced? What was the biggest challenge you faced, like in a general way, and then I'm gonna be more specific.
Okay, I think the fit in between technology and what is actually needed for the project was a process that took quite long, because we had a deep look into technologies that exist. And we figured out that there's actually no technology that made the whole process so easy and at the same time so accurate. So we had to develop something that is feasible at a design time that hasn't been there yet. And in this way, we delivered a package. But the idea, like the process from the idea to the package from a technical side was quite, a lot of work went in. Yeah.
And how was the biggest challenge you faced when designing the workflow between one set measurement and a digital planning?
Actually, the challenge has been the connection to what the customers actually use on a digital side, for example, a CAD software, because we have to make it as convenient as possible so they find themselves in a convenient area compared to their CAD software. But at the same time, we also have to think about new areas who haven't worked with CAD before, but are interested by using a product like that. So making our interface as much as familiar as they would know from their CAD system, and also the users who are not familiar with CAD also telling them that this is the more efficient way to measure.
And did you test it with, like, the users that you tested, were they professionals or was they more with the students?
Yeah, yeah. Actually, we have been working quite close with our colleagues at Festool. We have been reviewing our work like every few weeks, and then we have tested the process. We have tested the user experience design phases. So like the wireframes we made in order to get through all the steps you would like to go through in order to measure something. So this was a permanent discussion, and there's a lot more ahead beyond what you have seen right now, with eventualities that could occur during special areas.
Okay. Yeah, so I wanted to ask you, like, at the beginning, when you started developing the project, did you become like some feedback that you said, okay, wow, this feedback was really useful for me because it really like it was a big impact to, I don't know, to the last prototype or the last solution you found out?
Yeah, definitely a lot of steps. I think most went into the handheld. So the step to say, okay, let's put a giant screen on the handheld, made all the things we thought about before so much easier, because now we just said, okay, a screen like that, a touch screen, is so familiar when you come from a smartphone, for example. You know those smartphone CAD things or measurement apps, and now you just have them on your handheld. So this was a big game changer for us, and also things like the stick that you have seen on the last picture that you put on the handheld, because we always had this question of, okay, we really need this handheld in order to have a physical electronical device on point of measurement. So how do we get there? The easiest way was, okay, let's make it longer in some way, and at the same time make, for example, an feedback visible still. Yeah.
Okay.
I have a question relating to the handheld, because it has this peculiar shape with a kind of large round rim from the base of the handle to the top. So how come you went for this design? What's the functionality there about the rim?
Yeah, so the rim contains those reference points, and so there are two kinds of reference points, let's say. There are reflectors that reflecting the infrared light from the base station, and there are infrared LEDs on the handheld as well. This is what makes the position of the handheld visible for the base station. And those have to be visible from 360 degrees. So first of all, we have been thinking about something integrated in your handle whatsoever. But if you hide them with your hand, of course, the base station won't see it. So we said, okay, they have to be on the outside somewhere. But how do we make sure that nobody grabs it there? So we made like an shape, which is of course still this circle shape that we choose. That you cannot put your hands on from the outside. It just fits within your hand or around your hand, and then everything is still visible. And at the same time, we need to make sure that those points are also visible on the inside of the device. So this was the second reason why we said, okay, we have to use an external part that is also visible from the inside.
Got it. So it's the functionality, it's the triangulation of
the package is completely done by the technical needs.
And one more question about the handheld. The screen of the handheld device, it's a built-in screen. Is that correct?
It's a built-in screen. We also thought about making a connection to a smartphone, but then we figured out
that was basically lying on my I was like, obviously you would like maybe to get away from creating another level of electronics and maybe make something more detachable that you can take away with you, have your app on it, and that's it.
Yeah, that's the point, but there's maybe an easy answer. You have to make sure that you can get into angles that are below 90 degrees with the handheld. And smartphones have quite a big screen, and I think they're even increasing these days. So if you put a smartphone on it and thinking about 5 years, 10 years in future, I don't know, then the screen could be as big as you cannot reach an angle anymore without having the smartphone attached. Of course, then you could put your smartphone in one hand, the handheld in the other hand, but then the user experience is getting worse. So we decided to use a smaller screen compared to a smartphone, put it on there, but letting the interface in the way as you know it from a smartphone. But it's actually the size of a smartphone that is normally too big to be fit within the case that we have.
Okay. Yeah.
I have another question. It's and what comes next now? Like, is this gonna stay as a student project? Is there any chance to take it to further and bring it to the market?
Yeah, so this is a project study, and let's say the shareholder is Festool in this kind. So Festool is experiencing those inputs as fresh results for their maybe a strategy to plan projects, to plan anything. I'm not aware of actual products that they have on hold or maybe going to launch, but what they needed was any fresh inputs on the area of measuring. So for them, it's definitely something to have a look at when they think about new projects. But there's not like a timeline right now or a dedicated product that will launch in this way.
Okay, thank you.
Yeah, Adrian, before you go, one last question from our audience, from Mario Elise, who's a design engineer. He asks, how did you choose the product materials and did you test it in real environments with dust, wet, and construction debris?
Yeah, so since this is definitely a thing. For material, we choose the quite common ABS that Festool uses for most of their tools, but keep in mind that we have different materials. We have rubber, for example, on the handheld and so on. And for the point of dust, for example, that's a big thing because most of the time you are in areas that are quite dirty. So what we had to make sure was that no dust is getting into critical components. We made sure that this is the fact on the handheld. Of course, you always have a risk of getting any dust in the USB Type-C port or something. So this could be closed as well, of course. But the handheld is most of the time quite protected by yourself. For the base station, we made sure that everything is basically kind of sealed. So this has to be looked on later on when the development gets further. But first of all, we don't have any vents, anything that could let dust get into the device. And of course, you still have to clean a product like this. So the lenses are they make problems if they are dusty. So you have to clean them, of course. Yeah, but this is also a reason why we are talking about this sustainer from Festool, because it just protects your device from any environmental problems. Yeah.
Okay, thank you.
Thank you very much.
Congrats again on winning the New Talent Award. Of course, congrats to your two team colleagues for this project. And we really hope that, of course, this distinction from the jury will boost your careers of all three of you. And thanks for
Thank you
sharing.
very much again, and thanks for the opportunity. Yeah.
A pleasure. It is my pleasure to introduce the second New Talent winner, who will speak about his project today. The project is Structra Modular VSM. It is a compact modular medical device for hospital wards. It's designed by Zaki Razak. He is from the UK, and the project was done at Nottingham Trent University. The jury was highly impressed about this project due to its outstanding relevance for the healthcare delivery. It addresses the significant amount of time that nurses spend searching for equipment and information, running or hopefully walking from patient to patient and ward to ward. And this project actually excels at translating well-documented issues into a coherent hardware product with an intuitive digital support. And the jury was also impressed by the rigorous research process and a very professional level of execution, which shows a strong design maturity. This said, a warm welcome to you, Zaki, and we look forward to your presentation and from hearing more about Structra Modular VSM.
Hi there. Thank you so much for the opportunity. And I'll be happy to share the project that I've been working on throughout my final year at Northampton University. So Structra is a modular vital signs monitoring trolley where nurses would come to the patient to record the four extremely vital signs, which includes the blood pressure, body temperature, heart rate, and O2 levels. So the project was inspired by an incident where back in summer when I was doing an internship, I was in a hospital due to a severe allergy issue. And throughout that experience, 15 hours in the emergency ward, I just noticed there was so many problems with the nurses taking the vital signs. One of the problem the nurses that I saw was trying to locate the equipment, whereby the trolley was really messy. And there has been times where the nurses comes to me and then they would have to take recordings manually, either on a piece of paper with my details. There was also an instance where a nurse came to me and she was using her phone, and later at night, a nurse decided to come with me towards me to take my vital signs with another trolley just to record the vital signs onto their system. And yeah, so this was what happened to me last summer. And I decided to do more research about this, like how much time is wasted by the nurses. And on average, every nurse spend about like 10 minutes just trying to locate the trolley, finding the right equipment, making sure that the equipment are properly working to sanitize. And it adds up to roughly about 900 million just in time wasted. And I decided to dig further, and a lot of nurses shared issues of like sometimes when they get too busy, they would forget to return the trolley back properly and they would forget to charge it. And this, like, they would call it a hunt, trying to find the right trolley with all the equipment on board. And yeah, there was issues of accessibility where some of the equipment just doesn't work with together. And then nurses, when they are extremely busy, they would only have time towards the end of their day or shift to upload every patient reading that they have taken. And yeah, this is an example of like some of the issues gathered online from my research, where some hospitals couldn't afford to get new system where you could record digitally. They have to carry every single patient's files by hand, and that would just make the whole shift quite unbearable, where they have to go back to the office, collect the patient's file, find the trolley, bring it to them, log it manually on their pen and paper, or maybe sometimes personal devices, and then move on to the next patient before coming back to the office, manually uploading it one by one. There are some innovation in the medical space where POC trolley point of care has been introduced, but as we can see here, they are quite bulky, and like especially when nurses are tired, it would be such a hassle for them to bring two different trolleys just to take four vital signs. And throughout my project, I managed to get in contact with a medical center, which is a satellite building to our university. And it's exactly what I saw in the hospital, where the VSM trolley that they are using are extremely outdated. And they uses so many cables where they are touching the floor, just like the one I'm seeing here. And then yeah, there isn't dedicated storage for every equipment, where when nurses are rushing for their shift, they would just dump everything onto the basket to move on to the next patient. And the last picture, you can see that they are like sometimes they would struggle to find the right equipment, and they would just grab the trolley hoping that everything is in there. And looking at the market and trying to understand why a lot of hospitals can't afford to get the latest equipment, because it's simple, it's too expensive for them. And the more expensive machine usually would require dedicated connectors, compartments, where if they have to replace, it will cost them quite a lot in the future. And yeah, so initially I decided to take the project as like a modular system, and I developed several ways on trying to like maybe create dedicated compartments for every equipment, and we even include like a small screen for them to take down the readings digitally. And I initially presented to my university three concept, and everybody agreed with me on the idea of like a modular um, tray system. And I developed that model and then brought it back to the hospital that I initially reached out. And the nurses were quite happy with the system, but everyone mentioned about like having a trolley system would actually be more beneficial than the tray, because sometimes nurses will be carrying more than just the trolley. Sometimes they'll be carrying the extra drugs, so they would like to free up their hand. But the biggest thing that they brought up was actually a centralized recording unit. All the nurses kind of agreed that there's no standardized way for them to take the recording, either through pen and paper, and nurses have the tendency to rush what they write, and there might be an error in the recordings. Some nurses have been spotted using a mobile phone because it's easy for them, and this NHS has slowly rolling out iPad system, but it hasn't been standardized yet. So I decided to make that as my new direction for the project. And throughout my research, nurses would save 40 to 50% of their time if they just have a system where it's efficient, and making sure that all the equipments are on there. And yeah, they would really benefit. And if nurses can do their shift much easier, therefore there will be less problem in the system, and we as patients will get better treatment. So this was the development, trying to figure out what's the best way of doing the modular system, the best height for the trolley, how to maneuver it properly, and just to see how it would fit different equipment. And I had the opportunity for my internship company for additional feedback, especially on the engineering phase, just to see like how the assembly would be considered, and yeah, just developing a whole package now. And yeah, just trying to make sure that every cuff would have a dedicated compartment, but it can also be easily removed if it's needed for sanitization, or maybe the hospital decided to upgrade to different cuff. It would allow them to buy a bigger or a smaller cartridge. A small screen was added to also help with to collect the all four different equipment reading onto one single system. And yeah, just trying to figure out like what's the best ergonomics for the trolley. And right before I developed the final product, I decided to reach out again to the hospital that I've been working with, and just to see like how they would use the prototype. And yeah, everyone was quite happy. The trolley is much cleaner, neater, and there's a comparison between the current VSM trolley that they are using. And yeah, just more development to make sure that the system is properly suited and is the most efficient way on the package. And yep, just pictures of the development. And this is the final product. So I decided to call the product Structure. It's a compact VSM system that reimagines how vital signs and point-of care are delivered in the NHS ward. Throughout intensive user feedback, Structure combines the functionality of both VSM and POC trolley system while eliminating the need of cumbersome laptops, personal smartphones, and focus on the modularity organization, and also consider about like compatibility with future expansion. And yeah, one of the main goal of this project to make sure that every compartment would every product, every medical equipment would have its own dedicated compartment. So not only this would help with the sanitary aspect of it, but it will also encourage nurses to properly return the equipment properly back into the dedicated compartment, which allow them to improve their workflow, and making sure that before every shift, they know that every equipment is available on the trolley. And yeah, the system also incorporates ambient lighting. If when throughout the reading, if they notice that a patient's reading is there's an error, it would be behind the tablet system, and the tablet system uses a magnetic puck. And the reason why I decided to go for this kind of like puck that sticks behind the tablet system is because some hospitals have raised the concern whereby they wouldn't want to stick to a single platform. Maybe in the future they decided to switch. This would be the best option for them because they can just remove the plug and then attach it to a different tablet in the future. And yeah, there was a lot of consideration on like thoughtful storage, where there are dedicated slots to carry additional equipment. So rather than the nurses having to go back to the storage facility, trying to find the additional supply, maybe like the thermometer probe cover, there's a dedicated compartment where they could carry some extra. And there are special cutouts for the holster, especially for the thermometer and the SpO2 sensor for them to easily reach out and return it properly back. And yeah, the whole system uses a 4-in-1 Bluetooth system. So the whole point of the trolley is that it needs a way for all the devices to communicate onto a single platform before it's packaged and sent onto the system. And I worked with the Nottingham Trust group to develop the electronic medical record system, where once all the devices has logged in all the information, all the vital signs, it would then upload it to the system, and then the nurses can compare the before and after of the patient's recording. And yeah, there was a lot of like stuff that we have to consider about, like especially for cleanliness. So instead of the nurses throwing the sanitary product behind or in the basket, why not make it a dedicated compartment so it reminds them to sanitize the equipment after every patient, and to also consider about like maybe support in the future where if they decide to use a different sanitary product, because it's just a plug and play, they can just choose a different attachment to support their cleaning utensils that they prefer. And yeah, another request was actually dedicated recharging dock. So some nurses said that they spend time trying to find trolleys that are charged. So why not create a dedicated charging dock where the nurses, after every shift, they would have to return the dock properly. So not only this ensures that the dock is properly charged, but also helps with the nurses to locate the trolley where in the beginning of their shifts. And yeah, there's some other ergonomic consideration like height adjustment and tilt adjustment, which is really appreciated by the nurses. And then I also decided to include modular IO pods, so maybe in the future, if the device is needed to cater in maybe the ICU or maybe in the future as well, then hospital decided to use a different system, they could just swap to different IOs so that it still could be communicate with the future tools. And yeah, this is the submission model I submitted for the uni. And yeah, this is trolley and with the battery system, the lighting system, and yeah. And sorry. And a lot of the feedback was really nice, and some nurses actually appreciate how calming it looks. It doesn't look like a messy cable monster, some nurses have mentioned, and they just like the scalability. And some nurses are actually trying to push me to propose this to the NHS. And yeah, that's it. Thank you very much.
Thank you very much, Zaki. It's a very impressive presentation. And to everybody who's now watching, if you've got any questions to Zaki, please post them to the comments and we'll bring them in, or of course, reach out on LinkedIn. So congratulations on the award also to you, Zaki, and above all for this very complex project. So it's really holistic, from user research, observation, interviews, market analysis, even of different kind of products, to concept development, with prototyping, testing, and the whole range of what you would go through in product development. So, and what I really like is also that it is a truly human-centered approach, because you really took care about understanding the everyday of nurses and what the pain points are, and really found several approaches, design solutions for diverse pain points all in one. So it's a very impressive project, just as well as the Structra that we saw before. I wanted to ask you, because it's such a large and complex project, and you went on through so many different stages. Can you share a little bit with our co-designers who are listening about what helped you to keep the process structured and on track? Maybe about which methods or tools you used.
Okay, so basically, the biggest point of the project is actually on trying to maintain a good communication with the clients. So for instance, it's nurses and people who are in the medical scene where they have really tight schedule. So knowing that my clients or the people that I have to reach out will be hard to maintain a good timeline, it's just good for you to like plan out, because the project went on for like a couple of months. So it was actually like I would let them know in a couple of weeks that, hey, I'm already at this stage of the process and I would like to receive feedback in the coming weeks. So having a structured program where you spend a week on development and maybe let them know like, hey, I'm already developing this design. Could I get in touch with you in next week or in the next couple of weeks? So having like planning out what to do next is really important. And yeah, I like right when I went back to my university for my final year, I was kind of in luck because the uni just upgraded their workshop, and we had access to a lot of 3D printers. And yeah, we was just trying to be as resourceful as possible. Like knowing that I have access to 3D printers now, it would help speed up the whole prototyping process. And yeah, I think that helps a lot on the development, like having the opportunity, even if it's not a high fidelity model, maybe it's just to test certain parts, maybe it's the sliding mechanism. Yeah, testing the how it's easy to assemble, but also how easy to clean and sanitize, just making sure that all the stuff were considered before like developing the big model.
Yeah, it's essentially a proof of concept, almost MVP.
Yeah, I wanted to ask you, like, how long did it take for you, like when you start like the first idea and then to the end when you develop the project itself?
About 18 weeks.
18 weeks, okay.
Yeah.
Very quick.
Yeah,
I think.
expected more somehow. Okay.
Can you share a little bit which tools you used, maybe which design tools you used in the process?
So for sketching, I was trying to so I previously I preferred to do pen and paper sketches, just classic. But then my friend introduced me to Procreate, and I decided to take this opportunity to also learn digital drawing. So there was a good balance between both quick sketches on pen and paper and sometimes like sticky notes, just trying to get the idea out. And then when later I have much freer time, I would take the iPad out and just trying to practice how to sketch it out digitally. And yeah, it's really important, I think, balancing out what works best for you. And then for 3D modeling, I primarily use SolidWorks, and then the visuals are done in Keyshot. Yeah. And then
Talk so much about the digital element of Structra, but you also created actually like the digital product to put in information, patient information, and so on and so on. So there is also like an element of the digital service as well to the physical. So where did you develop the UI digital UX part?
So I decided to learn a new software again, like so Figma. So just trying to create quick mock-ups because I was in luck because I got in touch with the original NHS medical record designer, and and we both decided to work on the system where it's not it's not a revolution, it's just an evolution of what they have, but trying to make it much more simple because not everyone has to look through like an Excel page. Yeah, it's just trying to balance it out, but between like enough information, but also pleasant for the user to use.
Right. I'm wondering, I don't know if this happened, but was there a moment in this project where you got stuck and what helped you to get unstuck?
I think definitely like when I initially did the first concept, the tray system, and then all the nurses they like, we do not want the tray system because it requires us to use two hands. And there are times that nurses have to carry additional medicines for the patient. And initially I was like, oh, do I really have to go back to the original trolley design? And yeah, it was a bit of like, you know what, that's actually make this more of like a based on what the user requires, not what I think works well for them. And yeah, it's just trying to like making sure that the user knows and get how easy for them to get familiar
Mhm.
and how easy for them to adapt. There has been time as well for like the cuff system where the one of the nurses initially proposed that, oh, why don't you make the thermometer cover like a cartridge system? But then when I developed it and we brought it out, some nurses said like, oh, it's unsanitary. So now you have to go back to the previous design and see where you can actually improve on.
And with the experience that you have now, like after developing the project, could you like refine something? Like if you could start again, like over again, you just say, okay, I would have done this instead of that.
I think, yeah, I definitely would like to iterate more on the project because now that I've seen what like the users want, there's like some people mentioned actually this system if it could be packaged even smaller, right? Then it could be used in like more emergency, like maybe in the ambulance. I think they would really appreciate this kind of like more compact version. And yeah, I think definitely there's a lot of like improvement in terms of like maybe the tablet system because the current one requires like a push down system. But then some nurses actually prefer to like, oh, what if you can orient it vertically and maybe make it horizontal. And yeah, there's quite a lot of like stuff that could be improved. But yeah, I do see like there's a lot of like headroom for this project to be even better.
Well, it's already very studied, so I think like incremental improvement is always there, and even you showed like how much improvement there would be or room for improvement in existing products. I'm wondering, since it's such a very studied concept, did any healthcare companies come forward, or did you receive any interest from that field, actually from producers? And what would be maybe the challenges in getting this to market?
So yes, there has been a few companies that reached out expressing their interest to actually develop the product because the trolley design is quite simple. It's quite straightforward. But then it gets a bit complicated because if a single company that owns this system, right? But they don't make the additional medical equipment like the thermometer, the SpO2 sensor, the blood pressure. It's hard for them to tell the other company, hey, this is the new standard that we're gonna create. Would you be willing to accept the new standard change? So there's a lot of like trying to get every single company to say yes to a certain design language or like a certain standard. Even for like there was one time where I wanted to do all the device to be using Type C cable, and then some medical equipment they would say no because it's either too expensive or like there is no standardized, maybe like the Type C charging ports all at the bottom or all at the side. So that's one of the bigger issues in trying to get every single company to agree on a single standardized system.
Yeah, of course. Like the more you go towards implementation, the more you start to swim from the sea of compromise that you have to get through in order to get to the market, get within a price range, get within feasibility, but also still keep up your idea that is central to the product. So congratulations again. We really hope that winning the award and the recognition by the jury will further help you boost your career. And of course, very much hoping that Structra would someday come to life in whatever shape or form.
Thank you.
So yeah, thank you very much, Adrian and Zaki, and thank you very much for sharing with us the different sides and all your knowledge. It was a pleasure talking to you. And that's would be for today, right?
Yes, we've seen two awesome winner concepts today. And actually, if you're working on great UX, why not enter the awards and earn recognition from our jury of 14 esteemed experts from all around the world? You can still enter until May 15th. Have a look at our website, uxdesignawards.com.
So thank you again, everyone, for joining. And if you missed anything, we're gonna share the video in LinkedIn and also in our website and YouTube, so you can always rewatch it again. And great morning, day, and evening, and stay well wherever you are. And see you again soon.
And sign up to our newsletter if you want to know more about upcoming events and, of course, the awards itself. Stay well and have a nice time. See you soon again.
See you soon.
Bye-bye.